I promised one more video on this subject, so here it is. In this video, I'm going to investigate in some detail the claims made by Dr. Shiva Ayyadurai that there is something suspicious in the Michigan election results. I'll also look at some of the responses claiming to debunk his analysis. I'm going to do this by looking at the Kent County results and the plot that Dr. Shiva uses that he says looks suspicious. For background, there are two videos by Dr. Shiva that I'm using as source material, together with a video response by Matt Parker and a response by Naeem Kabir on medium.com. These are the links. I'll paste them in the comments too. If you've reached this video, you're probably already familiar with Dr. Shiva, his theory and the plot he uses, but I'll spend a few minutes describing this anyway. The first important thing to note is that in Michigan voting, it's possible to vote just for a party, i.e. all the Republican candidates or all the Democrat candidates on the ticket, or individually select each candidate in each election, President, Senate, Congress, etc. In this video, I'll call these straight party votes and individual candidate votes, SP and IC. If we ignore the minor parties and candidates, there are essentially four buckets of votes that we are interested in. Firstly, there's Republican straight party votes that I'll call RSP. There's Democrat straight party votes, DSP. And then there's Trump individual candidate votes, I'll call TIC, and Biden individual candidate votes, BIC. The total Trump votes will be RSP plus TIC, and the total Biden votes will be DSP plus BIC. Dr. Shiva's plot uses two terms derived from these four buckets of votes. On the x-axis, he uses the Republican straight party percentage. Calculated like this, RSP percent equals RSP divided by RSP plus DSP. He then calculates the Trump individual candidate percentage, TIC percent, which equals TIC divided by TIC plus BIC. On the y-axis, he plots the Trump IC percentage minus the Republican SP percentage. What he is saying is that he expects the Republican SP percentage to be a predictor of the percentage of Republicans in the precinct, and the y-axis parameter is how much the actual Trump IC percentage differs from the expected result. Here is the resulting Dr. Shiva plot using the Kent County data. The black line is the best polynomial fit through the data, in this case a third order fit. To identify the best fit through the data, I looked at a straight line and several polynomial fits of increasing order using the Bayesian information criterion. This confirmed that, contrary to what some people have claimed, a straight line fit is not the most parsimonious. I've shown this in detail in an article I wrote on medium.com. If you're interested, the URL is shown here. All the fitted lines in this video are the most parsimonious fit according to the Bayesian information criterion. I've seen a lot of discussion about whether it's valid for Dr. Shiva to subtract two percentages, as he does to calculate the y-axis parameter, so I'd like to address that here. A more normal way to check if there's a correlation between SP vote and IC vote would be to just plot the straight correlation between the two. I've shown this here on the left with the Dr. Shiva plot on the right. If the correlation is perfect, the data points should follow the straight diagonal line shown on the plot. The equivalent exact correlation on Dr. Shiva's plot is a straight horizontal line. We can easily show that Dr. Shiva's plot is just a simple transformation of the straight correlation plot. So Dr. Shiva's plot is just showing the difference between the actual result and the perfect correlation. One way to look at it is that he's actually just subtracting his predicted candidate vote percentage from the actual candidate vote percentage. As these are both based on the same population, the candidate vote, there's no problem with this subtraction. Another way to look at it is that nobody has said that the straight correlation plot is invalid. In fact, both Matt Parker and Naeem Kabir recommended it as a more suitable plot. If there's no issue with the correlation plot, then there's also no issue with Dr. Shiva's plot, as it's just mathematically the same thing, but just transformed. One other major criticism of Dr. Shiva's plot is the claim that if you plot the equivalent Biden plot, you see the same shape, and so the two plots cannot show a net change of votes. This criticism is one of the major planks in both Matt Parker's video and Naeem Kabir's article. I've done a couple of other videos precisely on that subject, but it's easy to show visually here that if we ignore the minor parties and candidates, the equivalent Biden plot is exactly the same as the Trump plot, but with inverted axes. This can be demonstrated by starting with the Trump plot, first inverting the x-axis, and then inverting the y-axis, and making the equivalent Biden plot. There's no need to plot the Biden plot. It doesn't tell you anything new unless there's a large vote for someone other than Trump or Biden. Now that we've defined the plot, let's try to understand the plot's normal behaviour and thus address Dr. Shiva's hypothesis. The four-bucket voting model is not very useful for modelling voters that switch their votes. To model vote switching, we need to introduce the concept of normally Republican and normally Democrat voters, so we can model what happens when their votes are switched, either fraudulently or by their own choice. We'll work out a bit later how to estimate who is normally for each party. So we will split each of the individual candidate vote buckets into two parts. We could also split the straight party buckets, but the model is sufficiently flexible and less complicated without this. We've now defined our normally Republican IC votes in two buckets, those voting for Trump and a separate bucket of those who have switched or had their vote switched to Biden. We've done the same thing for the normally Democrat IC votes. We now have 6 buckets of votes, and the total Trump votes will be RSP plus RICT plus DICT, and the Biden votes will be DSP plus DICB plus RICB. Using this voter model, we can investigate the behaviour of the Shiva plot to changes in voting percentages and to votes shifting between parties and candidates. In our investigations, we'll show both the Shiva plot and the straight correlation plot. This model is essentially the same or very similar to the models used in the following sources. There are some online interactive versions of this model that you can play with. I've put those links below as well. First, let's establish a simple baseline case. We'll set our voting model with a 50-50 split between straight party and candidate voting, and a baseline case with all Republicans voting for Trump and all Democrats voting for Biden. As expected, the correlation between SP and IC, shown on the upper plot, is exact and is a straight diagonal line. The lower Shiva plot follows what he said was the expected baseline in his first video, a horizontal straight line at 0. To start to understand the behaviour, let's consider a single precinct of, say, 100 voters. In our baseline, the votes would break down like this: 25 Republican straight party votes, 25 Trump IC votes, 25 Democrat straight party votes, and 25 Biden IC votes. The result is a dead heat, 50 to Trump and 50 to Biden. That precinct appears in the middle of the two plots. Now we'll increase the Republican straight party vote and reduce the Trump IC votes, just modelling more Republicans voting SP instead of IC, but with no overall change of Trump votes. So we make Republican SP votes 30 and Trump IC votes 20. Leave everything else the same. This is still a dead heat with 50 votes to Trump and 50 to Biden. But on the two plots, this precinct now appears further to the right and further down than the original. If we do the same thing for the Democrats, the point moves up and to the left. This is still a dead heat with 50 votes for Trump and 50 votes for Biden. We can see that without changing any votes between Trump and Biden, but just by changing the ratio of SP to IC votes for a single candidate, we can modify the correlation in either direction above or below the baseline. If we look at all the possible ranges of SP to IC vote ratios, including very extreme cases, we can see the possible regions that this single precinct can move to, even without switching any votes between candidates. Remember, this is just a single precinct with varying SP to IC percentages, but no vote changes between Trump and Biden. In every point here, the result is a dead heat, 50 to Trump and 50 to Biden. This already indicates that the behaviour of this correlation is likely to be very complicated and difficult to interpret. To investigate a bit further, let's go back to the baseline case, but show 11 precincts of varying Republican to Democrat ratios of 0% to 100%. We'll change each parameter in our model in isolation and see the effect. First, let's look at the effect of different SP to IC splits, as we just did for the single precinct. We confirm that just by changing the number of SP voters, the correlation is no longer matching. Note, as we said, no votes have changed in this scenario, just the split between SP and IC. All Republicans are still voting Trump, and all Democrats are still voting Biden. If we repeat the same thing for DSP, we get the blue lines shown here. We've confirmed that this correlation may not be very useful in some circumstances for determining if votes have shifted. Also, the plot cannot tell you anything about who has won the election. Note that the upper blue dotted line looks like Dr. Shiva's normal condition in his second video, but the lower red dotted line seems equally plausible. Now let's check what happens if we make some Republicans vote for Biden and some Democrats vote for Trump by changing the IC vote ratio with SP vote ratio kept constant. Let's say 20% of Republican IC voters vote for Biden. We get a straight line from no change from the baseline at the left-hand side to minus 20% at the right-hand side. Note that with the current settings, there are no Republican voters on the left and 100% Republican voters on the right. Also note that we've made a constant percentage shift. So we've shown that Dr. Shiva's initial expectation in his first video that this effect should be an offset horizontal line is not correct. Now let's say 10% of Democrat IC voters vote for Trump. We see a similar straight line with plus 10% on the left and 0% on the right. It seems that for these settings, the y-axis value at the extremes tells us the percentage of IC votes we've switched, with Democrats switching to Trump on the left and Republicans switching to Biden on the right. The sign tells us if Trump is gaining or losing votes. If we combine the two, we simply get the average of the two straight lines, the pink dotted line on these charts. Now let's look at what happens if, say, 20% of the Republican straight party voters shift to IC voting so that they can vote for Biden. In this scenario, two of our parameters change. We get the results shown here. The curve on the Shiva plot is starting to look like a familiar shape. The Y value on the right-hand extreme is still showing us the Republican IC vote percentage change for Trump, in this case, minus 16.7%. For completeness, let's do the same thing for the Dems. Note the shape is the same, but the x-axis is inverted because the Dem-heavy precincts are on the left. The changes we've looked at so far are fairly simple, as we've assumed that the four probabilities we defined are constant in all precincts, and in reality they don't need to be. Let's just try one variation here. Let's try varying SP with the Republican percentage and the Democrat percentage. We'll make the probability of voting SP increase as the percentage of a party's normal voters increases. In other words, we'll make a high likelihood of Republican SP vote in high Republican areas and a low likelihood of Republican SP vote in low Republican areas, and the same for Dems. This seems like something that might be reasonably expected. By doing this, we find that we can introduce an S-shape in the plot. Also, although the endpoints still indicate IC vote percentage, the curve at the end is so steep that this feature that we previously observed in the plot may not be useful. In real results, there may be no precincts with close to 0 or close to 100% votes for one candidate, so we may not have the data needed to deduce the crossing point. Using the basic model we've set up and some knowledge of its behaviour, we find it quite easy to match the shape of the Shiva plot and the straight correlation for the Kent County results, just with some tuning of our simple parameters. In this case, the parameters I've used are listed here. Unfortunately, we can find many solutions to match the shape that are completely different but produce a similar shape. Here's another possible solution that produces nearly the same correlation, the pink dotted line on this chart. We can see that it's hard to deduce anything only from the Dr. Shiva chart, or even from this correlation. The chart has so many degrees of freedom that it's not very useful on its own. We need more information to understand what really happened and correctly set the parameters in our voting model. Ideally, we would know these three things. We need to know how many normally Republican and normally Democrat voters we have. We need to know what percentage of the normally Republican and normally Democrat voters voted straight party. And finally, we need to know what percentage of the normally Republican and normally Democrat IC voters voted for their own presidential candidate and what percent voted for the other candidate. Fortunately, in this election, we have some other information to help us. We can look at the down ballot data. This gives us a way to categorize the percentage of normally Republican or Democrat voters independent of whether they voted for Trump or Biden. We look at how many vote for Republican and Democrat candidates down the ticket. So this is what we'll do. We'll determine the normally Republican and normally Democrat split from the down ballot votes. Then we'll determine the best fit for our parameters PRSP and PDSP from the actual results. Finally, we'll determine the best values for our remaining parameters to match the shape of the plot. First, we determine the normally Republican and Democrat split from the down ballot votes. This is a summary of the voting in the Kent County elections. We can see that the Republican plus Democrat vote is more than 95% of the vote, and in most cases more than 97%. Therefore, to simplify our model, we'll ignore the minor parties and candidates. Looking at just the Republican and Democrat votes, these are the results. The chart here shows the percentage for Republican and Democrat for each race, plotted against the number of Republican and Democrat votes in that race. If we add together all the votes for all the different races except for the presidential race, the data shows that Republicans got about 50.7% of the vote and Democrats about 49.3%. We can do this calculation for each precinct to find out PR and PD for each precinct. Remarkably, the overall straight party Republic versus Democrat vote percentages match almost exactly with the down ballot percentages. This plot shows the correlation, and it's very close. It turns out that Dr. Shiva was correct, that straight party vote is a good predictor of how Republican or Democrat a precinct is. Once we've determined PR and PD, we can determine the best fit for PRSP and PDSP. It turns out that the best fit for RSP is a second-order polynomial, shown on the left-hand plot. The best fit for DSP is a straight line, shown on the right-hand plot. Finally, we tune our other parameters to match the shape of the curve. There's no unique solution here, as Democrats could vote for Trump and Republicans could vote for Biden, and we can't easily distinguish. I tried to pick the solution that had the least number of vote switches, which meant that my model has nearly all Democrats voting for Biden, but some Republicans switching from Trump to Biden. I think this doesn't invalidate the model as long as we end up matching the actual results, as it's a statistical model and not attempting to model every unique voter. With some quick tuning, this is what I came up with for the two parameters. Trump's vote holds up in high Republican areas, but he's losing votes from expected Republicans in less Republican areas. Using the parameters we've derived for the voting model, we get a reasonably close match to the best fit polynomial, shown by the magenta dotted line on these charts. We concluded earlier that the Dr. Shiva plot is not necessarily the best plot for understanding the results. Now that we've defined our model better using the data available, we'll define another plot to view the data. A better correlation plot to do is probably the correlation of the candidate vote with the down ballot party vote. This means plotting Trump vote versus Republican down ticket vote and Biden vote versus Democrat down ticket vote. This is actually similar to what Dr. Shiva was plotting, in that it's actual versus expected, but calculates the expected independently from the presidential race, and the actual is the total vote, not just the IC vote. When we plot these new plots with the Kent County data, we see that the voting model is a very close match to the best fit polynomial. Again, the magenta line on these charts is the model. This plot is much easier to interpret than Dr. Shiva's plot because the x-axis is a much better estimate of the voting tendency in a prefect, and shifting votes in the presidential race never changes the x-axis. These plots are consistent and show that there is a shift of votes from Trump to Biden, with the biggest shift from the expected correlation happening around the middle of the curve and reducing either side of this. Using our model, we can now modify the candidate votes so that Trump's overall vote is in line with the down ballot Republican votes. If we do that, we get the following two plots. The left-hand plot is our new correlation, and the red points confirm the exact correlation, and I would argue show that this is a better plot for understanding the data. The Shiva plot then looks as shown on the right. It does show the same shift of votes as the left-hand plot, but it's more complex to interpret. Dr. Shiva was suspicious that his plot seemed to show that as the percentage of Republicans in a precinct increased, the vote shift to Biden seemed to increase in a linear fashion. If we use the down ballot data to define the percentage of Republicans in a precinct, we can test if this is correct. The left-hand plot shows the votes lost by Trump and gained by Biden from the expected down ballot voting ratios in each precinct. The right-hand plot shows the Trump loss as a percentage of Republicans in the precinct. Both plots have the percentage of Republicans in the precinct on the x-axis derived from the down ballot voting. We can see that the percentage shift is not increasing but is roughly constant at around 7 to 9% and actually reduces a little in high Republican areas. This seems plausible. I think Dr. Shiva has misinterpreted his chart, which is an easy thing to do, as we've seen its behaviour is not intuitive. So from our model and the analysis we've done so far, we can make the following conclusions about the presidential race. First, the net change of votes from the expected to the actual is approximately 13,500 votes, switching from Trump to Biden. This makes the difference from an expected narrow win to Trump of 50.7% to 49.3% to the actual result of a win to Biden with 53.1% to Trump's 46.9%. The net change of votes is clearly visible on the Shiva plot as a shift in each precinct. The overall shift appears as a curve with a similar shape but a steeper gradient, almost like a rotation about the 0 point of the chart. If we plot both the Trump and Biden plots, we can see the net shift in both plots. The shift is roughly constant with percentage of Republicans in a precinct, around 7 to 9%, but reduces slightly as the percentage of Republicans increases. With all this data and analysis, we can now step through the main claims and responses one by one. Is Dr. Shiva's key assumption valid? Dr. Shiva's analysis rests on the major assumption that you can use a party's straight party vote percentage to indicate the overall percentage of voters of that party in a precinct. Based on this, he expects a one-to-one correlation between Trump candidate vote percentage and Republican straight party percentage. This is why he picks the plot he does. It's a particular view of that correlation, with the exact one-to-one correlation becoming a horizontal line at 0 on his chart. This was his original normal line. He may have picked this plot because it allows the scale to be changed to examine the difference from the one-to-one correlation more closely. We've shown that there is a remarkably good correlation between the straight party percentage and the overall vote received by a party in the down ballot voting. I was surprised to see how good this correlation is. My conclusion is that Dr. Shiva's assumption is valid, at least for this county. Can you subtract percentages in the way that Dr. Shiva does? A lot of people have criticised Dr. Shiva for apparently subtracting percentages. Dr. Shiva's plot is simply a skewed correlation plot. If it's not valid to draw Dr. Shiva's plot, then it would also be not valid to draw a straight correlation plot, since one is just a transformation of the other. I therefore conclude that there's nothing wrong with Dr. Shiva's plot, as long as it's interpreted correctly. What he's actually subtracting is his predicted candidate vote percentage from the actual candidate vote percentage. And as these are both based on the same population, there's no problem with the subtraction. The interpretation is that if the value is negative, the candidate got a lower percentage of the candidate vote than predicted. The value is a percentage of the candidate vote. The fact that the correlation he expects is not seen does not invalidate the plot itself. My conclusion is that Dr. Shiva's plot with its subtraction feature is perfectly valid if it's interpreted correctly. Is Dr. Shiva's definition of a normal curve shape correct? Dr. Shiva initially defines a horizontal line as the expected or normal curve shape. To achieve a horizontal line across a large extent of this chart is possible, but it requires a strange distribution of votes that probably wouldn't be normal. I've investigated this more in one of my other videos. In his second video, Dr. Shiva modifies his definition of a normal shape to a curve. A simple voting model shows that this curve is one of the shapes that could be expected from plausible voting percentages, but by no means the only normal shape. My conclusion is that Dr. Shiva's first statement, that an offset horizontal straight line is normal, is false. This is not a normal shape. His second statement about the curved normal shape is misleading. It is a normal shape, but it's not the only normal shape. Could Dr. Shiva's chart show a net shift of votes from Trump to Biden? We've demonstrated in this video and in others that a net shift of votes from Trump to Biden can easily be seen in Dr. Shiva's plot if an initial baseline is assumed or somehow derived. It's also easy to show that neglecting minor parties, the equivalent Biden plot shows exactly the same net vote shift. My conclusion is, firstly, Dr. Shiva is correct. The chart can show a negative vote shift. Also, Matt Parker is not correct when he says that the Trump and Biden charts cannot show a net change of votes. And Matt Parker and Naeem Kabir are not correct when they plot the Biden plot and say that this disproves Dr. Shiva's theory because it apparently shows Biden also losing votes. I assume that this is due to a misunderstanding or a misinterpretation of what Dr. Shiva is saying. Were votes actually shifted from Trump to Biden? We've shown that if we derive the expected votes for Trump based on the down-ballot Republican votes, then Trump does indeed get fewer votes than expected, and this is shown on the plot. The analysis shows approximately 13,500 votes shifted from Trump to Biden. Dr. Shiva suggested 22,500 votes were shifted, but I couldn't repeat that number. This means Trump didn't get the votes expected, but doesn't provide evidence that there was any fraudulent vote switching. Some Republicans could have just voted for Biden. My conclusion is that Dr. Shiva is correct, that the data shows that Trump didn't get the votes that might be expected, but I don't agree with his actual number of votes. Is the shape of the curve suspicious? This is the fundamental claim for evidence of fraud by Dr. Shiva, and I think this is where the attention should really be focused. Dr. Shiva suggests that the plot looks horizontal at first and then has a downslope, which is suspicious. Other people have suggested that he's overfitting the data and a straight line fit is more reasonable. We have shown that a straight line fit is not actually the best fit, according to the well-established Bayesian information criterion. We've also shown that the best polynomial fit can be closely matched with a simple voting model using plausible parameter settings. My conclusion is that Dr. Shiva is not correct. The shape of the curve on its own is not suspicious. I also conclude that those saying Dr. Shiva has overfitted the data and a straight line fit would be better are also not correct. These are my overall conclusions from all the work I've done on Dr. Shiva's theory. Firstly, Dr. Shiva's analysis does not show conclusive proof that election fraud happened. There are plausible non-fraudulent explanations for the data shapes. Fraud can't be ruled out just by looking at the reported results, but there's nothing suspicious in the data shapes. Second, based on the down-ballot voting, Trump received about 13,500 votes fewer than might be expected, which was sufficient to go from a narrow win to a loss for him in this county. And thirdly, the plot used by Dr. Shiva is easily misinterpreted, and given there is down-ballot data available, there are other better plots that can be used to understand what is happening. I made some minor conclusions on some common responses. Firstly, the equivalent Biden plot is not inconsistent, and the shape of the Biden plot does not debunk Dr. Shiva's theory on its own. Secondly, what Dr. Shiva does with subtracting percentages is not invalid. He's merely showing a difference from an expected correlation. And thirdly, a straight line is generally not the best fit through the data, and Dr. Shiva is not necessarily overfitting the data with his piecewise fit. There are lots of other interesting videos and articles on this subject, and I've listed some of the ones that I've seen here. I've attempted to be as impartial as possible in this video, focus on the maths, and genuinely try to understand both points of view. If you think there's a mistake in my analysis, leave a comment below. I'll annotate the video with captions if I see any mistakes. I expect that this will be the last video I do on this subject. Until the next one.